28, 5, 26. Functions are a little bit pending, so let me go to the next problem. Functions little bit pending, so I'm going to the next problem. Yeah, please do this next problem. Please do this. So let me write def a of n column. Next one, inside the def function we are doing if n less than or equal to 1 column. So inside if we are doing inside if return. So return 0 or 1, it doesn't matter. But important thing is, remember, you are not printing. Please be careful. Else, remember, return 1 is nothing but you are not printing it. Until unless I will say print, it is not printed. Right? So else, so let's see the inside else. So print n minus 1, print n minus 1, yeah, perfect. Afterwards, a of n minus 1 function call. I think it is a recursion. Next one print n minus 2. Afterwards a of n minus 2. Afterwards print n minus 3. So remember, this is the part of the else, but it is a part of the a function. Right? So this is the, I think, a function. Let's go to the part of the a function. That's perfect. Now let's go to main program. I'm talking about main program. See the main program? Same line, right? Same line you can write. So write def, whichever place there. Same place I'm writing. So n is equal to int of input, enter the number. Afterwards, yeah, perfect. Afterwards, a of n function is called. Afterwards, print all numbers printed. All are printed. So this is the program. So what is the output of this? It is the most probable thing which can happen, right? In recursion, this is the best problem you can give in the exam. Can you try few minutes for this problem? Try few minutes for this problem. Few minutes you try for this. Yeah, I'm waiting for you. So I will give the answer. You please try your opinion. Right? Go ahead. Go ahead once. I will give answer within few minutes. What is the output of this program? So assume that enter the number. Yeah, you may say that enter the number. Sir, which number you enter? Let us assume I enter 5. Let us assume I enter 5. So, right, input string always returns string only. Input function always returns string only. So 5 string will be returned. But we are doing typecasting, it became 5. So n value 5. N value 5. N value 5. So a of 5 called. So you will go to main program. Here. Sorry, function you will go. Right? Then what is the output? Can you check now? Can you check what is the output? Try everyone. Try what is the output of this program. And one more thing is this recursive program contain, see, in the else part more than one statement. And more than one recursive call also, more than one recursive call. So the best thing what you can do is go in the form of a tree. Recursive program, go in the form of a tree. More than one function call, tree is better. More than one function call, tree is better. Right, and one more here, 5 statements are there, 5 or 6. Let's check, 1 here, 2 here, 3 here, 4 here, 5 here. Totally 5 statements are there. So we can start now. I am just doing here one time. Can you see here? Can you see here? A of 5. Go inside. Totally 5 statements. Right? First one, print n minus 1. So 4 will be printed. Now A of n minus 1. A of 4 is called. So remember, that is the meaning of recursion. Same story will repeat. Right, next one. Afterwards, right, I think here print n minus 2. I think 3 will be printed. So A of n minus 2. So A of 3. Again 5. Next one, lastly print n minus 3. So 2 will be printed. Now come here, A of 4. So best thing is leftmost function expand. Then we will think about the rightmost things. First expand leftmost thing. Leftmost function expand. I think now n value 4. So I think here 4 minus 1, 3 will be printed. A of 3 will be called. A of 3 will be called. Next one, print n minus 2. So it will be 2. I think some sound going on. Just wait 1 minute. Just wait 1 minute. I think now it's perfect. Yeah, so A of 4. So internally calling A of 3. Afterwards print n minus 2. So 2 will be printed. 2 will be printed. Next one is A of n minus 2. So A of 2 is called. A of 2 is called. Okay, fine. Lastly print n minus 3. So 1 will be printed. So leftmost function expand. Afterwards we'll think about rightmost. So same, n value now 3 now, n minus 1. So 2 will be printed. A of 2 called. Next one is n minus 2. So 1 will be printed. So A of 1 also called. Lastly n minus 3. So 0 will be printed. Right, leftmost one expand. Leftmost one almost completed. Leftmost one expand. So once again, A of 2. What is the answer? N minus 1. So 1 will be printed. A of 1 is called. Next one is, I think, 0 printed. A of 0 is called. Right, next one, last one is going to be n minus, I think it's a minus 1 printed. Right, until now everything is perfect. Now understand one important thing. A of 1 termination, stop it. See, n value less than or equal to 1 or 0, right? It is also termination, stop it. So if you observe clearly, this is A of 2, this is A of 3, right? See, so this is A of 3. I think this is also A of 3. You no need to do this again. Whatever work you are doing here, same thing you have to do. That is the reason leftmost people you do first. If needed, rightmost people will do. If needed, we will do rightmost people. Do leftmost people first. Right, now see the execution. So to complete this, these 5 people required. In the 5 people, first person available already. First, I think 4 will be printed. So this is done. Next one, A of 4 purpose you are going. So to complete this, these are required. First, this is required. So 3 will be printed. So to complete, right, to go further, this is required. To complete this, these 5 required. First, it is required. 2 will be printed. So to complete this one, these 4 required. To complete this one, these 4 required. First, this is required. So 1. Right, next one, I think termination. So leave it. 0 will be printed. A of 0 termination, leave it. Minus 1 will be printed. So after this is over, this is completed. So 1. Right, A of 1 termination, leave it. So 0. So remember now, until now, whatever I done for A of 3 purpose only, this entire thing is A of 3. A of 3, whatever output you got, this is A of 3 output. So this is, let me write here, 4, 3, 2, 1, 0, minus 1, 1, 0. Right, this is completed. Now let's go to 2 printed. So 2 printed. Afterwards, A of 2. I think A of 2 also required again. But A of 2, if you observe, this is A of 2. You no need to do again. What is A of 2? 1, 0, minus 1. 1, 0, minus 1. This is 1, 0, minus 1. So this also completed. 1 is 1 printed. Right? So fine, perfect. So now A of 4 completed. Afterwards, 3. Afterward, this one. 4, 3, 2, 1, 0, minus 1, 1, 0. This also complete. Afterwards, 2. Right? Perfect. This is the output. So I think it's a I will give numbers also. I will give numbers also. Let me write. It is a number 1 printed, number 2 printed, number 3 printed, number 4 printed, number 5 printed, number 6 printed, number 7 will be printed, number 8 printed, number 9 printed, 10, 11, 12, 13, 14, it is a 15, it is a 16, it is a 17, right? 18, 19, 20, 21, 22, right? 23. Lastly, this one. This is 23. 23rd number printed is 2. This is the output. Remember, if anyone is not getting, just I want to clear it out one thing. More than one function call, go in the form of a tree. More than one function call, go in the form of a tree. My request to all the people, recursive program execution. Stack you have to take it is stack only, but in the form of a tree. Why tree? More than one function call, please go in the form of a tree. It will become easy. And one more, while doing this, leftmost function call expand first. Because same thing may repeat on the right hand side. You no need to expand both at a time. Leftmost one expand first. You no need to do both the things at a time. Leftmost one expand, right? Right before expanding right side, please check already there on the left side or not. If there, please reuse it. Function calling pre-order. Function execution is post-order. Function execution is post-order. If you want output, post-order you go. If you want function calling pre-order, so first he called, okay, next he called, next he called, next he called. This is called pre-order. Function calling is pre-order, function execution is post-order. I think in the data structure, you will find, in the data structure tree chapter, you will find out the pre-order, post-order. So let me write now, function calling, I am writing here. Function calling, pre-order, function execution, post-order. Function calling is pre-order, function execution is post-order. And one more thing I want to say to all the people. One more thing I want to say to all the people. Right? One more thing I want to say. Please be careful. Recursive program. Recursive program. Recursive program. Recursive program. Right? You have to use stack. Okay, that's okay. Stack used. More than one function call. Recursive program. More than one function call. So stack only use in tree format. Tree form use. Recursive program, you have to use stack. True. Recursive program, you have to use stack. I am okay with that. More than one function call is there. Tree form you have to use. Stack only use tree form. It is a stack only. First he will be pushed in the stack. First he will be pushed inside stack. Next he will be pushed. 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 Right? But after, right, this person will complete first. That is the meaning of post order. The person who called last, he will complete first. That is the meaning of stack. What is the meaning of stack? Last in, first out. Whoever came late, he will go first. So calling first called person is A5, A4, A3, A2, A1. First one is A5, last one is A1. But A1 will complete first. That is the reason stack. Right? So recursive program, you can use stack, no problem. More than one function call is there. Use in the tree format. Use a tree format. This also please take care. It is the most expected question in the exam. In the exam, most expected question is this one. In the exam, it is the most expected question. Most expected question in the exam is this one. Right? Be careful. I hope you got it. I hope you people got it. Let me go for one more problem. Let me go for one more problem. One more problem. Let me go. Right? With that, we can say that almost functions are completed. This is going to be interesting problem. This may come in the exam also. Extension of previous problem. Extension of previous problem. Let me do this one. One more example. One more example. Can you see this one? DEF A of n column if n less than or equal to 1. Same, similar kind of thing, some different story. Return 5. It doesn't matter because you are not printing. If you print, then only output will come. Return 5 only for namesake. Else. Right, be careful here. Many function calls may be there. Print n minus 1, b of n minus 1. Remember, a function calling a is calling b. Remember this. Next one is going to be print n minus 2, b of n minus 2, print n minus 3. I think that is perfect. That is perfect. I think that is over. So let's go to main program. Let's go to main program. I'm writing the main program here. A of n print all printed. If anything required, I will change it. Don't worry. This is a function. This is a function. Let me write beside. I think a calling b na. Let's go for b also. Def b of n column go inside. If n less than or equal to 1, return 10. Else be careful. Print n minus 3. Print n minus 3. A of n minus 2. Print n minus 2. A of n minus 1. Print n minus 1. Let me write here. So n is equal to int of input, enter the number. Okay, perfect. Next, a of n print all are printed. Okay, fine. I think I have to clear it out. You can keep anyway. So what I done is I written the main program here. Right? So I think a function I done, a function I written, b function I written, a function I written, b function I written. So main program also I written. If anyone is not getting clarity, so let me write one time. Let me write. Everyone be careful. Let me write. It is a main program. It is a main. Okay, perfect. It is a main program. It is a function. It is a b function. It is a function. It is A function. It is a B function. It's a function, it's a B function, right? It's the main program. Start now, enter the number. So I enter 5. So I think afterwards it will become 5, become a string. It's a Python program. It's a Python program 5. Next one, so n value becomes 5 because you are doing typecasting. It will become an integer a of 5. Right? A of 5 is called. Go to the A function. But the only difference between this program and previous program is previously A calling A. Now A calling B, B calling A. It's indirect recursion. It's going to be one more important one. This may come in the exam. This may come in the exam. I request everyone. I request everyone. This may come in the exam. Please take care. If you are okay with this, you are okay with most of the things. Right? This may come in the exam. Be careful. So A function calling, but A calling B, but B calling back A. So it is indirect recursion. So, and one more thing is inside A, if you observe else part, 1, 2, 3, 4, 5. In the else part, there are 5 lines. But if you go to the B function, else part, how many? Let's check. It's a 1, it's a 2, it is a 3, it's a 4, it is also 5. Right? That is also 5 people, this is also 5. But remember, A call B, B will call A. It's an indirect recursion. Means what is the meaning? First level A people, second level B people, third level A people, fourth level B people. In the previous diagram, everywhere A only. See, every level A only. First level A people, second level also A people, third level also A people, fourth level also A people, everywhere A people. But here first level A people, second level B people. So like that. So I will execute once. Right? See everyone. See everyone. A of 5 is called first. Internally, it will call 5 people. And one more, my suggestion to all of you is more than one function call. Please go in the form of a tree. A 5 people, B also 5 people. But remember, A will call in the next level B people. So let's go for here. What is the first one? Right? Print n minus 1. So 4 will be printed. So B function called, B of 4 called. Next one, print n minus 2. So I think 3 will be printed. So B of n minus 2. So 3 will be called. Lastly, print n minus 3. I think 2 will be printed. So A calling B. And one more thing is leftmost one expand. Don't expand rightmost one. If needed, we will expand. You can do, it's a time waste. This is called dynamic programming. If necessary, do. Otherwise, don't do. So B of 4. Let's go to the B. B also contain 5 people. B also contain 5 people. B also contain 5 people. Let's go to the B. In the B, what is the first one? In the B else part, if you observe, right? I think print n minus 3. N minus 3. I think 1. Afterwards, A of n minus 2. A of 2. Afterwards, print n minus 2. So 2 printed. Afterwards, A n minus 1. A n minus 1. So A of 3. Next one, A of 3. That's okay. Fine, perfect. Print n minus 1. So 3 will be printed. 3 will be printed. And one more thing if you observe, first is decrementing more, lastly is decrementing less. So bigger function you do first. Left or right doesn't matter. Bigger one you do because bigger one may generate some more smaller people also. So here bigger one is B of 4, B of 3, B of 4. I expanded B of 4. Right? Here bigger one is A of 3. I am expanding this. You can expand this also, no issue. But bigger one expands so that bigger one can contain internally so many smaller people also. So no problem at all. Let's see. Right, next one. Go to the A function. A function, same story. A function, same story. Can you go to the A function one time? First one. A function, first one. Print n minus 1. So I think 2 will be printed. Afterwards, B of n minus 1. B of 2. Right, next one. Print n minus 2. So I think 1 will be printed. B of n minus 2. So B of 1. Lastly, print n minus 3. So 0 will be printed. So remember, first level A people, second level B people, third level A people, fourth level B people. So like that. Now, bigger one expand. Whichever bigger one expand this. I think almost it is the end of the story. If required, we'll expand further also. Bigger one I am expanding. Sir, you said leftmost one? Yes, normally leftmost one. System will do leftmost one only first. That is the reason function calling is pre-order. System will do pre-order only. So common sense will be used by humans only, right? System cannot use. System will follow some rules. How the system will follow? It will call in the pre-order. But as a human, to save the time, we can do some minimizations. Alright, bigger one expand so that bigger one contains smaller one also. Let's go to B of 2. In the B of 2 first one, print n minus 3. So I think minus 1. So A of n minus 3. So minus 1 is called. That is also fine. Sorry, print n minus 3 afterwards A of n minus 2. N minus 2. So 0. It is 0. It is 0 call. Next one is going to be A of 0, right? Print n minus 2, n minus 2, so it is 0. Afterwards, A of n minus 1, it is A of 1. Lastly, print n minus 1, I think 1. That's perfect. I think until now you've done. So let's go by one. So from the bottom, right, I think you know very well, execution is done in the post order. From the bottom it will be done. If you observe clearly this one, if required some more people will expand, it's okay. If you see clearly this one, this is the termination, output is going to be minus 1 0 1. B of 2, B of 1 is anyhow termination, nothing to do, right? Next one. So bigger one you expanded. When you are going from the bottom, at anywhere B of 2 there, you can use it. If not there, no problem. Now I think A of 2 not there, that is the reason I am expanding. Not there, expand. Go to the A. In the A first one, print n minus 1. So I think 1 printed. A of, right, B of n minus 1, so 1. Right, that is okay. Next one, print n minus 2, so 0. B of n minus 2, B of 0. Lastly, print n minus 3, so minus 1. Now, if you observe clearly, these are terminations, so stop it. The output of this one is going to be, so how much it is? 1 0 minus 1. That is the output. At anywhere required, we will expand. Don't worry. And now I'm from the bottom. I am doing whichever possible. If it is available, I am using. Not available, I am doing again. Okay. Until now, everything is okay. But this person still not dancing. Is not available. If not available, expand. See, not available. Nowhere available. Expand. How? 5 people. Same like previous problem only, but A calling B. If you want to check, first level A people, second level B people. Third level A people, fourth level B people, fifth level A people again. That is the only difference. Can you go to B of 3? B of 3, if you observe, else part you go. Print n minus 3. So 0. A of n minus 2. A of 1. Okay. Print n minus 2. So 1. Next one, A of n minus 1. So B of 2. Sorry, A of 2. Lastly, print n minus 1. So I think 2. So if you observe clearly, A of 2 somewhere. What is A of 2? 1 0 minus 1. Already there, you can use it. So somewhere it is available. I used it. I think no more expansions required. Now go for execution. So remember, function execution is post order. See the output how I am printing. Function execution order is post order. What is the meaning of post order? Parent will be printed after children's only. Parent last. So can I print this? No. After children's only. Can I print this? Yes. You don't have children. First it will be printed. So afterwards, these children. But can I print parent? No. After children's only. Can I print this? Yes. Because you don't have children. Now come here. If anyone don't know pre-order, post-order, in that tree chapter you will get to know. Now to complete this one, these all are required. First is required. So 1. Afterwards, this is termination, leave. Afterwards 0, okay. Afterwards termination, leave, minus 1. So now it is completed successfully. Now 2. Go to the 2. Now A of 3 to complete this is required. So in that 2 first. Afterwards you have to go there. For this, these are required, which will goes to minus 1 0 1. So this is also complete. Afterwards 1. Afterwards termination, so 0. So this is complete, means that is over. Lastly 3. Now this is over means this is completed. Then next 3. This is over means next I will go here. To complete this, this is required. So which will goes to 0. Afterwards A of 1 termination. Afterwards 1. But this will goes to 1 0 minus 1. Afterwards 2. This is completed. Lastly 2. So this is the output. Right? So please check if anything is wrong. Because of it's a big problem, there may be a chance that small wrong also. If you think small wrong also, you can comment in the comment section. I'm going to help you. Hello everyone, my name is Subbarao Gunta. I have been guiding students for competitive examinations since 2007. Based on my experience, I would like to share a few suggestions that can make your preparation more effective. I hope you are enjoying these lectures. My sincere request is please complete the entire subject without skipping any lecture. Every lecture is connected. While attending the classes, write your own notes and execute every program that I demonstrate. I strongly believe in that one time writing is equal to 10 times reading. And programming is learned only through practice, right? While doing the story at any point of time, if I am writing the program, you also write, you also do changes whatever you want. Instead of blindly listening whatever I am saying, right? You also write the program, you also try whatever you want. So you have to make the notes also, and because of it's a programming, it's better to practice also. If you have any doubts, ask them in the comment section or join our doubt solving group. Our doubt solvers will solve. And you can see class notes of these all lectures in the group also. The link of the group will be provided in the description. Please have a look one time. And not only that, as soon as you complete any subject, assignment also please write. Assignment link also we are providing in the description. Lastly, you write the mock tests also, those links also provided. Once you finish the subject, make sure you solve the assignment and then attempt the mock test. That's where real learning will start. We will provide the same quality of teaching, assignments, mock test, and doubt support for each and every subject. Before I conclude, I would like to share one belief that is very close to my heart. I sincerely believe that quality education should be accessible to every talented student. No student should miss quality education because of financial limitations. That's why we have kept most of the courses at exam prep tool affordable so that every deserving student can benefit. Thank you for your support. Stay consistent, trust the process, and keep learning, keep growing. Small wrong also, right? You can comment in the comment section. I will help you. Yeah, in the tomorrow's class, we will see the remaining problems. Tomorrow, OOPS concept is starting. Don't miss it. Tomorrow, 6 o'clock, sharply, I will start the class.